Everything so far has gone one direction. The client asks, the server answers. This episode, two final pieces: how the messages actually travel and the plot twist, how a server can ask things of you. Start with travel. MCP messages need a transport. MCP officially supports two. Transport 1, Standard Input and Output, stdio. The host spawns the server as a child process on the same machine. Messages flow through that process's st-in and st-out, the same pipes a terminal uses, just carrying JSON-RPC. No network, no latency. This is your local server, a file system connector, a local database, a code tool that runs inside your project. Transport 2, Streamable HTTP. The server lives in the cloud. The client sends each JSON-RPC message as an HTTP post. For long-running operations, the server streams results back using server-sent events. The client gets data incrementally, not all at once. One server reachable by many clients at once. This is your remote server, a hosted GitHub connector, a Sentry integration, a company-wide calendar service.
And the moment a server is remote, you need a door policy. MCP's recommendation is OAuth 2.0. The client gets a bearer token from an authorization server. It attaches that token as an authorization header on every request. The server checks it before doing anything. Same JSON-RPC messages underneath, just with identity on top. Now the twist. Everything until now the client drove, but MCP gives the server three ways to reach back through the client. The first is sampling. A server often needs a language model to think, but it does not want to bundle its own model or manage API keys. So it asks the client, "You already have a model? Run this for me." A real example. A flight tool pulls 47 fare options and needs to reason over them. Instead of bundling its own AI, it sends a sampling request up the client. Analyze these options, find the three best value ones. The client's model does the thinking. The answer flows back down and you are in the loop. The client shows you the sampling request before sending it and the response before using it. You can inspect, edit, or reject either step. The server borrows intelligence. It never seizes control. The second is elicitation. Sometimes the server needs more from you. A missing detail, a confirmation, a decision. Instead of failing silently, it pauses and asks.
Here is what that looks like. A booking tool is about to charge a card. It sends an elicitation request, a small structured form with three fields. Confirm the total, choose window or aisle, add travel insurance, yes or no. The client renders this as real UI. You fill it in, the server continues with your answers. One rule the spec enforces: elicitation may never ask for passwords, API keys, or credentials. Full stop. The third is routes, quieter than the other two. Routes are file paths the client shares with the server. Here are the directories that matter for this session, your project folder, your templates. A well-behaved server uses them to stay in its lane. Important note, routes are coordination, not security. Your operating system's file permissions are the real guard. Two more features worth knowing. Logging. Servers can send structured debug messages to the client at configurable levels, so you can trace what is happening inside a server's reasoning without its full console output. And tasks, an experimental feature for long-running work the client can check back on later, rather than holding an open connection for minutes. So here is the full picture. Messages travel over stdio on your machine, or HTTP with OAuth when the server is remote. The relationship is two-way. Through sampling, the server borrows your model. Through elicitation, it asks the user. Through routes, it learns its scope. In every case, the client stays the gatekeeper. We now understand the complete protocol. The primitives, the wire, the transports, both directions. But every result we have seen is still text and structured data. Here is the frontier question. What if a tool could hand back something you can actually click, drag, and interact with? A real interface living inside the chat? That is MCP Apps. That is next. If the two-way street clicked, subscribe. The advanced half of the series starts now. See you in episode 5.